First of all, as you've been told probably a million times, we read the question carefully and we see that we're being asked to find the values of m for which the equation has real roots. This tells us that if we vary the value of m, then sometimes the equation will have real roots and sometimes it won't. We should be on the lookout for the word roots, because at this stage in your mathematical journey, that will often indicate that the equation is a quadratic. So looking at the equation, we notice it has the m, it also has x squared terms, x terms and constants. Of course, the value of the letter m is going to vary. So, we know what the situation is now. We're dealing with a quadratic, and we have to find out whether it has real roots or not, depending on the value of m. And the way we find out about real roots is we find the discriminant, so called because it discriminates between different cases of roots. There's always a risk of confusion in these questions because we have the x and the m, but what you need to see is that changing the letter m just gives us different quadratics, so it doesn't change the fact that we're essentially dealing with a quadratic equation. So let's get on with finding the discriminant. The first thing we need to do towards finding the discriminant is to turn the equation into a quadratic equal to 0. So we have 4x squared plus 8x minus 8 equals m times 4x minus 3. So the first job is to open that bracket up, which gives us 4mx minus 3m. And then if we subtract those terms from both sides, we're going to get our 4x squared. We'll have 8 take away 4m times x, and then we'll have plus 3m take away 8, and that will equal 0. So now for the discriminant, which can be denoted by a triangle, we need b squared minus 4ac. And you'll probably remember that the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac over 2a, well, there is our discriminant, and it discriminates because if it's less than 0, then we can't, in the real numbers, take a square root of it, so it won't give us any real roots if it's less than 0. So what's a, b and c? It's always worth making very clear for yourself what they are, and notice that I'm including what the sign is here and here. Very common error that occurs in these questions is if we have a minus there, to ignore it, and then it all goes wrong. Okay, so b squared minus 4ac is 8 minus 4m squared minus 4 times a times c. This gives us 64 minus 2 lots of 8 times 4m plus 4m minus 4m squared minus 48m plus 128. At this stage you might see that we've got lots of even numbers involved, and we can divide every term by 2, and if we look a bit closer, 4, and in fact we can divide it all by 16. So if we take a factor of 16 out, then the m squared term is minus 4m squared, which is 16m squared, so that just leaves m squared. And for the m term, we have the 2 times 8 times 4, which divided by 16 leaves us with 4, so that's take away 4, and the 48 divided by 4 is 3, so that's minus 7m. And then for the constant, 4 16s in 64, and there are 8 in 128, so that gives us 12. For real roots, we need the discriminant to be greater than or equal to 0. And to determine this, we don't need to worry about the 16 because it won't change whether the whole thing is positive or not. So we can just look at m squared minus 7m plus 12 being greater than or equal to 0. So, in order to factorise this, which is the easiest way of finding out, we have a look at the factors of 12, 1 and 12, 2 and 6, 3 and 4. And because the final term is positive and the m term is negative, all these would have to be negative because they'll multiply to a positive and add to a negative. And we can see that we have the minus 3 and minus 4. So that gives us m minus 3 times m minus 4 greater than or equal to 0. Now at this point, it's a good idea to think about when this is actually equal to 0. And that's of course going to be when m minus 3 is 0, so m is 3, or when m minus 4 is 0, so that's m equals 4. We also will benefit from just sketching it, so there is our quadratic. We know it's that way up because m squared is positive, and there is the x-axis, and we know that it crosses at 3 and at 4. And from this diagram we can see that our quadratic here greater than 0 here and is less than 0 here. So that means the bits we need for our solution are this part here. This gives us m is less than or equal to 3, and this portion, which gives us m is greater than or equal to 4. We must remember to include or between these two because we need to make clear that we understand that they are distinct. A number can't be less than or equal to 3 and greater or equal to 4. So if we miss the or out, we're showing a lack of understanding. There is another way of writing this, which is to say that m belongs to, that's what that symbol means, from minus infinity up to 3, the square bracket tells us 3 is included, or between 4 and infinity. And that's a notation you'll find useful when considering functions in A2. Now it's always nice to be able to check our answers, but in this question it's quite difficult because if we try different values of m, what we'll end up doing is having to solve a quadratic, and the risk of making a mistake there is just as great as it is in the first place. So it's not easy to see how to check this. But if you had plenty of time, perhaps at the end of the exam, what you could do is just try the value m equals 4. You'll see why in a second. The good thing about m equals 4 is because square root in the formula is then 0, so we don't get two different roots. So if we put m into our equation, then we would hope to get repeated roots. And one thing we can spot straight away here is everything divides by 4, so we can make life a lot easier just by dividing through by 4. And then that gives us, by subtracting the 4x, we get minus 2x on this side, add the 3, we get plus 1. And then that may be a familiar looking quadratic because it's just x minus 1 times x minus 1, which is x minus 1 squared. And sure enough, we have the repeated root, which is x equals 1. Now this doesn't tell us that we were right in our work before, but it certainly doesn't tell us that we got it wrong. An interesting thing to look at is what do we mean by a repeated root in this situation? And one way we can think about this question is to think about each side of the equation being a different geometrical object which we can graph. So we'd have y equals 4x squared plus 8x minus 8, and we have y equals m times 4x minus 3. So we could sketch these. Let's have a look at the first one. We can take a factor of 4 out, so that gives us x squared plus 2x minus 2. And you can probably see that the bracket there we can't factorise, so what we'll do is complete the square. So that would give us x plus 1 squared, and the 1 comes from halving the coefficient of x in the quadratic. We then have to subtract 1 squared because we've got an extra 1 squared coming from the x plus 1 squared when it's opened up, and then we've got our original minus 2. And that gives us, when we simplify it, we've got 4 times x plus 1 squared. These two end terms become minus 3 times the 4 gives us minus 12. So let's sketch that. Well, it's going to have that sort of shape. It's a positive quadratic. The minimum point comes when this bracket equals 0, because that's the smallest we can make a square. So that comes when x is minus 1. So that means we have a point here which has an x value of minus 1, and when we make the 4x plus 1 squared to 0, then we can see straight away that the y value will be minus 12. Now we want to add the x-axis onto here. So the x-axis is when y is 0, so that means it's when 4x plus 1 squared has to equal 12. Therefore x plus 1 squared is 3, and x plus 1 is plus or minus square root of 3. Now we know that a quadratic curve is symmetrical, so this plus or minus root 3 is telling us that the curve will cross either root 3 that way, plus root 3, or minus root 3. And now, because root 3 is greater than 1, and our minimum is at minus 1, we know that the y-axis must be somewhere like that. Now we need to consider our other equation. So this is tricky because this changes with the value of m. So this represents lots of lines, infinitely many in fact. But one thing we might notice is that if we want to find out when y is equal to 0, then that tells us that m times 4x minus 3 is 0, which tells us that this happens when m is 0, or when 4x minus 3 is 0. That tells us that 4x would be 3, and so x is 3 over 4. Now a quick check will tell you that this point here, which is root 3 take away 1, is actually less than 3/4. So the point represented by this x equals 3/4, which is of course when y is 0, so it's on the x-axis, is just outside our quadratic here. So now we know all our lines go through this blue point. So we could have a line here, and that has two roots. It's crossing our quadratic in two places. Or we could have a line going that way. That's a bad line, it's meant to go through that point there. But you can see the idea, that line would have two roots as well. But we can also see that there are lines which will not cross our quadratic. So we could have a line up here, for example. We can also see that there will be a line that just touches the quadratic going through that point down here, and there will be another one somewhere up here. It's meant to touch. And those represent, this one represents m equals 3, and this one represents m equals 4. And we can tell that by thinking about the gradient of this line here, which is 4m. So as m gets larger, the gradient gets larger. Now, you wouldn't do this in an exam, obviously, but it's useful to have a look at this sort of thing, because this question can be confusing, because we're starting with a quadratic in x and then we end up with a quadratic in m, and it's easy to get confused about what's actually going on, and this shows you what's happening. So it's a useful bit of deeper knowledge. There's also another nice little thing we can do regarding repeated roots, which is that if we have repeating roots, that tells us that the line would be a tangent to the curve. And for a tangent, that tells us that the gradient of the curve and the line would have to be the same, as well as the point where they meet. So we can work these out quite easily. So to find the tangent to the curve, we have to differentiate. So dy by dx is 8x plus 8. For the line, if we write it in the form of a multiple times x plus a constant, then we know the multiple of x is the gradient, and we'd get that by differentiating as well, of course. Then we get this. And if we consider the case when m is equal to 4, that gives us 16 for the gradient of the line. So if it's a tangent, that means the gradient of the curve would also be 16, which would give us 8x is equal to 8 and x is equal to 1. Now, if x is equal to 1, then the y value of the curve would be 4 times 1 squared plus 8 times 1, take away 8, which is 4. So, these calculations tell us that we have a tangent to the curve at 1, 4 with a gradient of 16. And now considering the line, if we have m equal to 4 and x equal to 1, then y would be 4 times 1 take away 3, which is also 4. So that tells us that the line and the curve have a gradient of 16 at the point 1, 4, and therefore the line is a tangent to the curve. We can also use dynamic graphing software to have a look at the question. So first of all, we'll type in the left hand side. I'm typing XX. You can use the up button for doing powers, but for squares you may as well just type XX plus 8x take away 8, and there's our quadratic. For the right hand side we need a variable value m, so we're going to add a slider, call it m. Okay, then we must click on the arrow so we don't get more sliders next time we click. So now we type in m times 4x minus 3, and as expected we get our line. If we look at the line, we can see that the value of m is here, and that as we increase that will increase the multiple or coefficient of x, which, as we know from y equals mx plus c, will increase the gradient. So up we go. As we can see, it's cutting the quadratic in two places, but as we increase m, some point you can see that it just seems to move to the right. It's hard to see, so one thing we can do is to change the ratio between the axes. This means the axes are not in scale anymore, but it does mean we can see more clearly what's happening. And then using my mouse wheel I can expand it, and we can now certainly see that the line is outside the quadratic and therefore there are no roots. Go back to 3, we can see it's touching, and then go up to 4, it's touching again, and then past 4 you can see it's cutting it in 2 places, here and here. Now the other thing we can do is, when we tackled the question algebraically, we subtracted the right hand side from both sides, leaving us with 0 on the right hand side. So we can do that nice and easily in Geogebra by doing f take away g. And this is in fact the new quadratic that we found the discriminant for when we solved this problem algebraically. Now what happens is, you can see that that quadratic is below 0 between here and here, and as we increase the value of m, it more clearly goes below the x-axis, or the y equals 0 line. Now as we slide m back towards 4, when we get to 4, it is tangent to the x-axis, and as we continue it stays above the x-axis, therefore no roots. Goes, when we get to 3, m equals 3, it's touching again, so 1 root, and then it dips below the 2 roots again. Now there's lots more playing with Geogebra we could do on this question, but I think that's probably enough for now.